Okay, in this video I'm going to show you guys how to use MD Solids. There's a little trick to opening it. You're going to need to find this DWG TrueView on your desktop and open that first. And as soon as it opens, your screen might look a little different than mine. Just simply minimize it. Don't need it anymore. We have to open that before we open MD Solids. Then go ahead and find MD Solids 4.0. Open that. And your screen should look similar to mine. We're going to want to find trusses. Then we're going to select new truss. And I want you to change the number of spaces here. 10 should be fine for each. Let's do 10 and 10. Then select OK, and it'll create this little grid. Some pretty simple commands over on the left. Create, erase, members, support, loads. Let's start with creating members. And what you need to realize, we're going to click and then pull. And then this will only snap where these gray lines intersect, like right there. I can't do a member here. I'd have to make more grid spaces if I wanted to. So we're going to do a really simple truss, something like that. And let's do one up here, one down here. We're going to connect that, that, and that. We should have already gone over 2J M plus R, and this bridge has to satisfy 2J M plus R. So members, of course, are the green lines, the joints are all the dots, and our reactions are 3. We'll talk more about that later. The next thing we want is to create a support. Oh, and by the way, if you want to erase, so I can just click on erase member, and I can just simply trace over it to erase it. Okay, so now we're going to create a support. We're going to go to the far left end and pull down. That creates what's called a roller, that little circle. We're going to click on the other end and pull down. That creates another roller. That's not good. We need a pin and a roller. A pin has a triangle symbol. So with either one of them, we're going to then click and pull to the right, and that should change it. So you need one pin, one roller. Then finally, we're going to create a load. So click on load, and this just needs to be in the middle somewhere. It has to be at a joint. If you don't have a joint right at the middle, it could be off to the side. That's fine. It could be on the top, it could be on the bottom, and we're just simply going to pull down. The magnitude doesn't matter. We're going to leave it at 1 and click enter. You are done. So your bridge is statically determinate if it does the following thing. I'm going to click on compute right here, and if you see this screen, then you are good to go. Let me explain what this is. T means tension, C means compression, 0 means nothing. So those are the forces acting on that bridge. Compression, the balsa wood in our case is pushing together. Tension, the balsa wood is pulling apart. That will help how you design your bridge. You may want to double up some members in certain places where there's more tension or more compression. If your screen does not look like this, then you need to back up and remember that MD Solids will not compute your bridge unless it satisfies 2J M plus R.